Hi there, welcome back on my channel where we experiment CG workflows to make cool art. You've been a lot to ask for beginner-friendly tutorials about Houdini. I figured it's October, well, let's make some pumpkins. So in this pumpkin hell tutorial, I'm finally taking the time to talk more in details about procedural modeling, trying to make it as easy as possible to follow, but don't get desperate if you can't make it yet or grasp everything. There's a reason it's called pumpkin hell. It's a lot of information in 1 hour, and I still picked a very challenging topic for beginners. FYI, project files are available from my official Patreons. Without further ado, let's get started. This first part focuses on the procedural setup of the pumpkin, so let's dive in. So let's start by dropping a geo network, and inside we're gonna drop a circle. So we're gonna start using this circle as a section for our pumpkin. So we're gonna turn that into a polygon. So this allows us to control the amount of divisions, and that will affect the final amount of polygon in our pumpkin. Let's set that on 24 for now, and we're gonna open this arc so we can actually trim a section of the pumpkin. So we want something like 90 minus 90. Let's set that to maybe closed arc, just so we see what's going on. And the idea to generate this pumpkin is gonna be to revolve this section around itself so that we get a proper mesh. So I'm trying with a revolve node, but the problem is that it's not gonna allow us to get all the variation we would find into a pumpkin. So there are some edges we would like to be shorter, kind of things like that. So we're gonna try to find another way to actually revolve the shape around itself. So that's not the way we're gonna use it. So let's open this arc. And what we're gonna need to do first is to set up another circle. And we're gonna change its orientation as a flat kind of plane. And let's set it to polygon. So the divisions will control the amount of sections that are gonna be copied, and we'll use a copy to point to copy in the first input or initial circle, and in the second one or new circle. Let's rename those. Just to make it clear, this is the pumpkin section, and it's now copied, but it's looking pretty weird. It's not what we would expect, so we just need the orientation along curve to actually get the proper orientation of our section. So what's going on is that the copy to point is using the normals of the geometry to orient the section. So by default, those normals are pointing down, and this orientation along curve is setting them in a way that follow the tangent direction of our circle. And there are different tangent types, as you can see. I'm gonna leave it to the default one, the average. And yeah, the result is pretty successful. Now we need to draw some polygons on top, so we'll use the skin node to generate some polygons. Now we need to close it. Let's enable VWrap. So the skin node connected our curves together in a way that looks like a sphere. If we increase the amount of divisions, everything seems to work properly. Now we need to introduce some variation in terms of scale so that we get some pumpkin effect, I would say. And to introduce those changes, we're gonna need to set what we call an attribute in Houdini. That will define a weight for the scale of each point, and once the section is copied, it's gonna apply the scale. So let's make a test. We could drop an attribute randomizer. By default, it's randomizing the color, and as we can see, each section got a different color, but we could apply this concept to the P scale. And now each section got a different scale. So that's the general idea. Now we want something a bit more flexible so that we got complete control over those repetitions. So instead of using attribute randomizer, we will create our own setup using a pointvop. This is a very powerful node because it allows you to access all the components of your geometry, position, normals, point number, etc., and visually be able to access Houdini's functions and manipulate data. So we'll use a bind node to export an attribute called pscale, and we'll use a random function and feed the point number in it so that at every point it assigns a random value between 0 and 1. And now, as you can see, if we check out the spreadsheet, we got a p-scale attribute with values that are changing between 0 and 1. So that's the exact same thing that we did with the attribute randomizer. The difference is that we also had like a fit range that basically allow you to remap those values. So the minimum destination, you could say I want a scale of 0.719. But well, for now, we don't want any randomization. What we want is a consistent variation along those points. So we'll use a sine function and we'll feed the point number in it. So if you remember your math lessons, the sine is creating some kind of wave, some consistent oscillations. And we'll use a multiply to increase this oscillation or decrease it. So we are creating a parameter with a default value of 1 or whatever you want. And we're going to call this parameter intensity. We'll also create another parameter to control the frequency of those oscillations. So let's copy in past and we'll call that frequency. So if we change the default value, we are changing the amount of repetitions. So that's pretty cool. We'll just leave that to 1 and call that frequency. And those parameters are now accessible upstream on this pointvop node. So we're gonna need to find a balance between the initial amount of divisions and the frequency of our sine. So let's probably reduce that now. So I'm kind of limited on my slider, so I'm gonna need to edit the parameter interface, and let's say on my frequency increase the float range to 3. All right, so I'm gonna leave it like this, and we're gonna keep going. So we got this fit range that basically remap the values generated by the sine function, and if we play with the source min and source max, we can kind of contrast this wave to make it more or less buff. And of course, the destination min and max would control the overall scale of the final section. Okay, so we're gonna expose those using promote parameter so that we can access them upstream. And actually, let's make this nice and clean. We'll drop a folder and put these parameters inside, and we'll call this folder remap. So I'm calling that min input, max input, minimum scale, and max scale, just to make this more clear. All right. So actually, in that case, I think we might want to reverse the values between max scale and min scale, but let's see. So playing a bit with those sliders to see what it's gonna look like, but yeah, I think we should reduce max scale, and we got more like a pumpkin effect going on. So that's pretty cool. Yeah, probably wanna leave that to 0 and 1. Okay, let's keep going. We're gonna call that p-scale. Press C to access those colors. Pretty handy shortcut. Now we wanna isolate some points based on the p-scale so that we can make those edges sharper, like a legit pumpkin. So we're gonna create a group expression, and we're gonna create this group based on the scale attribute, the p-scale. So we'll call this group inside point, and we'll say a little expression like at to say it's an attribute, p-scale greater than this value, 0.94. So we could try something a bit greater, like 0.95. And let's set that to point, of course. So we got a proper point group, and now let's try to blast everything but this group. So let's delete non-selected, and now we got a proper group that contains the smaller section. So that will be defined by this value. And of course, we don't want to change that manually. So we'll do a copy parameter on the mean scale and pass it as a relative reference in here, in this expression. So right click, pass relative reference, and this expression is basically applying the parameter that's sticking to the mean scale. So we are changing the sign, and yeah, it seems to work fine. So we'll just use a little subtraction, like at the threshold. Yeah, ideally I'd like to keep a line, some lines of points. So maybe there's something I did wrong here. Yeah, maybe something more like this, so that we get just points. And what's cool now is that we can promote this group. Promoting is basically converting. And we're gonna convert this point group into edges so that we can select these areas. Now we wanna get rid of the small edges, so let's include only elements on the boundary. Awesome, now we can use this group to make the pumpkin much sharper. So we'll use a polybevel to call this inside point group that had actually been converted into edges. And if we increase the distance, well, we see some additional faces, and we're gonna use that. And let's make sure to export this edge fillet polygon, which correspond to the face that have been created. And we can call this group into poly extrude. So edge fillet polys, and let's, in that case, decrease the distance. So we are pushing those polygons inside. So as soon as we'll subdivide this pumpkin, it's gonna look much better. So let's try that. We're gonna drop a subdivide node that is a classic Catmull-Clark subdivision. Set that to flat shaded actually. And yeah, here we go. It's like we got some nice pinch effect in the cavities, and it's really helping selling the pumpkin look, I think. Now, so depending on how much we are extruding these edges, well, it's gonna look more or less pinched. So it's great, but we need to do some more shaping now. So we're gonna control the radius of the pumpkin section to give it more like a cool shape. And actually, we're gonna create a group based on the first point and the last points, so that we can control the top and the bottom separately. So it's easy. The first point, let's call it base, is the point number 0. Set that the group type to point. Now to procedurally select the last point, I usually like to use a group by range. So this node is very useful because it can help you control all kind of selection. So we're gonna call it end. And as you can see, you can control how much you wanna trim the selection or do some offset and stuff like that. So it's pretty fun. So let's set the end to 1 and invert range so that we just extract the last point. So we're gonna use a soft transform. Soft transform is very useful because it's like a regular transform, but with a kind of fall off that will include all the other points. So let's use the base as an example. I'm gonna decrease the translate Y, and we can include more or less of the neighbor point. That's pretty cool. Probably we can increase the divisions here. Yeah, trying to get a nice shape. So let's apply color for that one. We'll call that soft transform top. And we're gonna create a soft transform for the bottom. So let's change the group to end. All right, and let's adapt the translate Y. So something like that maybe. Oh, no. Okay, soft radius. Here we go. We can also change the soft type to get different kind of fall off. So Metaball is usually my favorite. I'm pretty happy with that. Let's see how it's looking now. And yeah, it's looking much more like a pumpkin, I guess. So it's a good base. Now we need more work to leave the creepy procedural zone we are in. So we're gonna do that by first introducing some variation in the frequency. So right now everything is very consistent and that might feel a bit off. So we'll reuse the random function that we saw earlier. And okay, let's connect the point number into the random so that every point number got a random value. And we're gonna use a multiply. So we'll multiply that by the frequency. And those random values, as we saw, are going from 0 to 1. So we may wanna remap those. Okay, let's make some room. You can maximize window, by the way, using Control B. All right, much better. And we're gonna set a minimum value. So 0, that might be a problem. So the minimum value will be 1. And we'll just change the destination max to introduce those variation. So now we got some smaller slice and some bigger ones. That's much better. I guess would also depend on your pumpkin. Like some are feeling very uniform, maybe for some more stylized one, or I don't know, up to you. But in case you need it, you got this maximum variation and the minimum value should be 1. Okay, we can introduce some seed so that we can generate different result. So we'll just add a parameter we'll call seed. And we'll connect that after point number. And now if we change the seed, we get different result. As simple as that. So as you can see, some cavities are feeling very soft because looks like the group isn't working properly. Maybe the threshold I added was too much. So I'm reducing that. And yeah, I think it's doing the trick. At this point, we want to add some actual distortion. So a mountain node, got the height, element size, is pretty straightforward. And we can scale this noise actually. And by default, it's looking kind of too much like a rock, I would say. So we may want to change the type to, let's say, sparse convolution and reduce the roughness. Okay, maybe something more like that. And as you can see, if we increase the height too much, well, in that case, we don't see much. Maybe let's increase more. Yeah, we see some faces with intersection. So you have to know that the mountain node is displacing points based on the normal direction. So we can generate the normal direction with a facet node and use an attribute blur to blur this normal, which is stored in an attribute called n, capital N. So if we visualize this attribute, the normal, we see that using the attribute blur is making the direction much more uniform. And in that case, preventing some intersection. Yep, so without with, it's looking much cleaner, you agree? So okay, we'll create a network box that we'll call deformation, just to clarify a bit this setup. And we can play a bit more with the mountain. So by default, the position of this noise is 0, 0, 0. I would recommend to change it all the time, like leaving to 0 those values is pretty bad idea since our model is centered. And yeah, let's play with those. I want something kind of subtle. I don't want something that looks too much like a rock or something. And yeah, that's pretty much it for this element. So this second part will focus on modeling the stem of the pumpkin. All right, so we're gonna first extract the position of the stem, which would be at the top. So we created this group called end. And yeah, let's just delete non-selected and fuse the points because we want to extract just one point. So if we increase the snap distance, it's gonna end up eventually fusing at the center. Sweet. So what we can do is drop a line that will drive the direction of our stem, and we'll do a copy to point so that we can position this line on the point we extracted. So let's merge this with our precedent result. And yeah, here we go. I'm gonna do a bit of shaping. So that would be of the overall length. Let's set a few points on this line so that we can bend it. So we'll use a bend SOP and set the direction to 1. And capture length, we want to capture, let's say, 0.6, and try to bend it. Okay, let's maybe increase that. And yeah, the bend, I'm looking for something that twists a little bit. Maybe I should increase that and move a bit the origin of this bend. Okay, I'm gonna actually change the capture origin, like lift it a little, like 0.1, so that it's going straight at the beginning and then starting to bend. All right, let's trim it a little bit, and I think that should work. So we're gonna design now the cross section of this stem. So we'll use another circle. I love using circles. And increase the divisions. So we'll use a sweep node, and we'll connect the second input to this circle, which is the cross section. So by default, our circle is way too big. And like we have a pipe right now. That's not so much what we want. So we need to do a bit of shaping. It's a nice pipe, I agree, but we want something looking more organic. So we'll do a selection of points using a group range. And we'll set that to point. And we'll increase this parameter to select a few points. Okay, let's actually increase that and increase the selection. We'll call that group select, going for something very original. And we'll use a soft transform like we did before, and we'll call this select group and scale it down. So by default, soft radius may be a bit too high for this scale. So yeah, we get some interesting result. Just want something that looks like a vine or something, like a cross section of a vine. So it's looking like a star now, but we want something that looks a bit soft. I think in that situation that might just work. Yeah. Let's maybe change the soft type to metable, or actually linear isn't bad. Okay, I'm just gonna leave that to cubic. This is what we get. So it's a bit better. Now we need some extra shaping. So the scale is very uniform right now. We can actually change that using apply scale along curve. So if you're using an older version of Houdini, I'm using Houdini 18 right now, and this is what the sweep looked like, but it used to look pretty different and wouldn't have this feature out of the box. So yeah, Houdini 18. And we can introduce some twist, so either full twist or partial twist. So I'm usually using partial twist for this kind of thing, just to get some subtle variations. And we'll create some cap on this geometry, so that should close this stem. So we'll use single polygon. Looks like trying to generate quads isn't always possible. Triangle fan, triangle, well, at this point, I'd rather just keep it to single polygon, really, but trying some other option just in case. Okay, I think this is safe to use. We'll extract the generated face. So the group is called patch in that case. And we're gonna call it into a poly extrude. Do a little inset and increase the distance so that it's kind of following the past shape. So it's like nice extension kind of thing. Okay, pretty happy with that. Yep. Let's see. Ta-da! You got a pumpkin. So now that we have a pumpkin model ready, it's time to carve it. Regarding the pattern that we're gonna carve, I gathered a bunch of different faces into a PSD file. I found those stencil on some website. I'm dropping a link in description. Otherwise, well, feel free to do something more personal or whatever comes to your mind. Well, probably better than me at drawing, so I will just do something quick. Let's say that's done. So let's have the PSD. And in Houdini, we're going to use a node that is part of the SideFX Labs tool. So make sure that the tools are up to date. If you don't have them, restart Houdini. And then you should be able to see this node, the trace PSD file. So let's just grab the Photoshop file we created. And as you can see, there is a layer to extract, and we need to click on the plus. And from there, we can extract any layer present in this PSD. So it's important that the white correspond to the part of the face you want to use. And it actually creates a group per layer. So that's going to be handy. I'll set up something real quick. So let's extract all of those. And we'll use a simple blast operation to extract the different groups. In that case, layer pattern A. Then we'll have the layer pattern B. You get the idea, right? So there would be a smarter way to do that, especially if we have a lot of layers to extract, but I don't want to confuse you, so we'll just go for this simple method, and we'll use a switch to actually be able to swap those inputs. Okay, so from there, what we want to do is trying to project this to our geometry. So we're gonna first need to initialize the position and rotation. So far, we should need to rotate it in X 90 degree. Yep, got the better orientation, and deal with the depth. So we want something that is pretty close to our geometry, I guess. But anyway, we'll use some projection method, and I think that should do the trick. So let's merge those, and okay, let's fine tune that. I'll apply the color so that we can see a bit better what's going on with this stencil. Spooky. So we could actually increase the size a little bit of this mask, taking much more space on the pumpkin. I'm renaming that transform scale, and I'm gonna drop another transform. This one will be in charge of rotation, and it will rotate around the pumpkin if we want to find a better place to apply our stencil. So here it's looking all right, I guess. Yeah, pretty happy with that. Let's try to use a ray node. So the ray node is able to project the first input on the second one. So let's add a null just for organization's sake and connect the second input to this one. And from there's nothing happening. Let's change the method to minimum distance, and it'll try to wrap this geometry on the second input, which is in this case the pumpkin. Now it's pretty tricky because the stencil is getting distorted by the cavities of the second input. So I'm using a smooth node so that we can attenuate these cavities, make the pumpkin smoother, and it's gonna try to project on this variant. Can also use the scale of the ray to basically reduce the projection effect. Okay, let's try without and with. Yeah, sounds about right. let's increase that way more. Okay, let's say we're happy with that. And we're gonna move on and basically make a volume out of this flat surface. To do that, I'm gonna first use a peak node, and the peak will transform the surface based on the normal direction. So if we increase the distance, you see that it's like inflating because it's following the normals. Okay, so something like that. Then we're gonna need to extrude it. So also playing with the scale to see the deformation effects. Okay, so the extrude, let's decrease that. So we're gonna need to generate the output back. All right. Now we want the distance of the poly extrude to be set up in a way that we make sure it's gonna intersect. So let's copy the peak distance and paste it as relative reference. Gonna make it negative and multiply by 2 so that it goes in the proper direction. And now we just got this expression that control the thickness. And we'll just use the peak to control it. At this point, we won't touch the extrude, but the peak node. So we want to make sure that it's properly crossing the geometry. I'll call that peak depth. So you probably noticed our object turned darker, which means we needed to reverse the normals. And yeah, from there we got a pretty good setup. I'm gonna clean something. Let's see, maybe adjust the scale. So we kind of see the limitation of this technique once we scale up the mask, actually. Yeah, it's like distorting a bit too much around the eyes. So maybe we'll adjust that a bit later. Let's move on. So we want to convert this as an actual volume with voxel so that we are able to manipulate those volumes and subtract them and stuff. So we'll see in a bit. I'm just getting rid of the stem for now. We'll merge it back later. I just want the pumpkin. So VDB from polygon is turning your geometry and filling it with voxels. In that case, a voxel size of 0.05 seems alright, but let's try to convert it into polygon. Okay, so if we press W to check the wireframe, we see it's a bit too big, and if we try to reduce voxel size, nothing's happening because the volume is not closed. So one way would be to use a fuse to actually fuse the points that we had on top and bottom. So we can reuse the groups that we created before, and it will just try to fuse those points together. So if we increase the snap distance, here we go. So that should help closing our geometry. And if we try the VDB from polygon, it's now able to voxelize this into a proper volume. And we can even go lower and it should keep working. Yeah, it conserves all the detail that we had. And we can use adaptivity to reduce some polygons if needed. But we'll see, maybe we'll do that later with a polyradius. Now that's great, but we also need to turn the stencil into a VDB so that we can do operations between those two. And it's a good practice to have the exact same voxel size between volumes to avoid artifacts. So let's just pass as relative reference so that we get a consistent voxel size. And we'll use a VDB combine to combine them. And what we want to do is set it to SDF difference. So that would be the equivalent of Boolean for the VDBs. And more specifically, SDF, because there are different types of VDBs. Now that's great, but we don't see the inside yet. So we need to generate a volume for the inside and subtract it with our current VDB. So let's use a VDB reshape, and it's pretty handy because you can set it to erode and it will remove some voxel, like the borders of the voxel. And from there we can also smooth it. So we can assume that the inside's not looking the same that the outside, of course. And we'll probably add some noise and stuff to make it look more interesting later. So yeah, from there, let's try to subtract this inside volume. And here we go. We can actually see that this pumpkin has been carved and the flesh has been removed. And maybe we'll put a candle, like just a point light or something inside to get some interesting effect once we are dealing with the lighting. In the meantime, I want to add the stem that we removed. So let's add a null here that will call output stem. And let's use an object merge. So I don't want to mess my network, so I'll just like to use some object merge to do some connection that wouldn't be aesthetically pleasing, let's say. So this way we still have the stem, and we'll subdivide it a little bit. Should probably apply some normals to our model. Actually, let's set it later after the merge. So we'll deal with that later. In the meantime, we're gonna keep working and then start assigning some colors to see what's going on. Gonna do a separation between the inside and the outside. So the outside could be something orange, like a pumpkin color. And for the flesh, we're gonna need first to convert the inside. So let's use a convert VDB on the volume of the inside. So setting the adaptivity to 0 so that we get something dense enough to transfer. And let's set a brighter color, something yellowish. Yeah. And we'll use an attribute transfer to actually transfer this color on the points of this one. Attribute transfer. By default, that might be a bit too high in terms of value. So we just want to transfer the color attribute, it's called CD. And distance threshold, let's reduce that and increase blend width. So it's a bit weird because I think we should reduce adaptivity to 0 actually. And yeah, from there, blend width should work a bit better. Okay, that's cool, but I think for a pumpkin that might be a bit too thin. I would assume that carving something that thin would be very difficult. So let's actually go inside the VDB, reshape. I'm gonna apply a color to this node because it's a pretty important one. And let's increase, let's say, to 10, 15, and we see how it's getting much thicker. That's pretty cool. So I'll increase the blend width, maybe a bit the distance threshold, so to keep some sharpness. Here we go. So review time. I think the carvings are alright, but it's looking too sharp and we want to give a more natural look to it. But first I want to address the distortion around the eyes because the mask isn't projected properly. So we'll use maybe a bent node so that that should help wrapping this mask a little bit better around the geometry. So we can increase the bend and change the direction, the capture length. And actually that's going to be a tricky one, I guess, because we should probably set the bend node actually at the very beginning before doing all those transforms and stuff. And set the proper direction. So let's see, can press enter to see the gizmo, and that would be in X. Okay, so capture length, let's reduce that. Now that's interesting, but it's only bending one side. We'd like it to bend on both sides, and changing capture origins not gonna help. So one way would be to make a reference of this node using Ctrl-Alt-Shift-R. And as you can see, all the parameters have basically been instanced using those expressions. And we can do is do a negative of the captured direction X, and that will basically reverse the direction of this bend. And as soon as we change the bend of the first node, we get now a proper symmetrical bending. Okay, now we just need the proper orientation, so it's minus 80, something like that. And well, we already got something a bit cleaner in my opinion. Let's use the ray node. Let's set that to 0 just to compare. Yeah, I think it's really helping. Okay, let's see. Yeah, I'm much happier with this shape. Now it looks like our stencil is not deep enough, so it's not cutting everything. Let's increase the distance. And as soon as we increase it, we now can carve all the thickness of this pumpkin. It's time for the finishing touches. So the first thing I'd like to do is introduce some breakups on this geometry. Right now, the way this is cutting our pumpkin is too sharp and too regular. So we're gonna introduce some variations. And the first thing I wanna do is extract some group based on these divisions here. So one thing we could do is output the group of these back faces. And we're gonna use a group expand. So we'll do a bit of group manipulation from here. And it's very handy, and there's no other software that can procedurally do that, where we can set a group and expand it. So this is the feature available in Houdini 18, so it's not available if you have a previous version. And we can set a new name for the output group. So we'll call that group side. And let's say now we want to subtract the initial back group. So we can take this new group sides, and do some operation like a subtraction to actually remove the initial faces of extrude back here. Now all we get is a portion of the side faces, and that's gonna be pretty handy because we gonna use a peak node to inflate them. So remember, this is transforming primitives based on their normals. So let's use these group sides and increase the distance. So this would help us kind of faking some bevel effect. So let's try that. Let's plug it here, gonna make some room. And let's check out the result. So right now, nothing much happening because we need to increase a little bit the group expand. It's probably not intersecting yet, so we need to increase to something like 8 steps. And we start getting some more interesting edges. It's not as sharp as before, and I'm really liking this kind of effect. So we could try to even go further. Maybe we could increase the peak to get a wider cut. And also play with group expand a bit more. So I'm gonna turn it green just so we remember to dial this parameter. Yeah, I'm going a bit extreme, but you see the idea, right? It's a bit too much because it's removing a portion of the nose, but the mouth got a pretty interesting effect. It's gonna add up on creepiness. Cool. So moving on, the peak is creating some interesting effects, as you can see, but let's say we don't want it to apply everywhere. In that case, we should mix the original shape of our stencil with the peak one. So what we can do is import the point position using an import point attribute. The input would be the first input, and it's gonna bring the P attribute, which corresponds to the point position. And let's do the same for the second input. Now we can use a mix node to actually mix those two vectors, the positions, and the bias is controlling like the opacity between those two layers. Now we're gonna create a mask from a turbulence. So turb noise is gonna help us bringing some noise, and we're gonna visualize it by connecting it as well into the color attribute. So let's connect the output of this in here. Now we see that it's pretty dull, so we're gonna contrast it a little bit. Actually a lot. So something like that, and let's increase the frequency so that we get more patterns going on, and probably increase roughness to get some smaller frequencies. Yeah. Could also play with noise type, but usually pretty happy with alligator noise. And we'll expose some parameters so that we can control all of these features upstream. All right, so it's already pretty interesting. We got some breakups and more irregularities going on this cut. So that's pretty cool. So changing the frequency and the contrast of this turbulence will help getting some interesting effect. Then again, it depends also on what kind of style you want to give to your pumpkin. If it's something pretty cute, you want to probably keep things pretty sharp, or in my case, I'm looking for something pretty spooky. So having some irregularities tends to make it look more creepy, I guess. And I'm kind of liking that. Yeah, something like that. Pretty happy with this. So from there, we're gonna... Okay, so that would control the blending, the overall blending of these two different geometries. Okay, so from there we could also detail the inside. That's feeling very smooth right now. So gaining back here, we had this VDB smooth, and what we can do is convert it back into polygon. And from there, let's use our favorite mountain sop. So as you can see, or maybe not. Okay, I forgot to convert that in polygons. That's better. As you can see, now it's tend to look like a rock, so may not be the best. Let's try to tweak that a little bit to give some more organic look. So probably gonna reduce roughness and adjust the height. Should play also with the noise type. So I'll copy this VDB from polygons to set it, convert it back into a volume so that we can do our SDF operations. So let's call that mountain noise inside or something. It's just an important parameter. So from there, everything seems to work. We now got some more details inside. It's also bringing some pretty cool colors, in my opinion, with transfer attributes. So that's pretty nice. Maybe we want to dial that down, but okay. From there, I'm gonna actually play a bit more with this noise. Could increase that. And actually, this setup is kind of spilling a bit too much. So instead of transferring the inside color to the outside, we might actually try to do the opposite. So I'm gonna be clear. Let's take the initial outside geometry, so this one, and instead of converting the inside, we'll use this. Okay, we'll use the outside and transfer it. So it should work a bit better, but we need to swap those colors. So let's just Control X, Control V those colors. And yeah, here we go. So yeah, I think it's better that in this situation, if we have a bit of spilling to the inside, it's less important. If we try to change the face with 4 drawings, well, that's not looking like anything. It's pretty hard to read, so I guess some might need some adjustments. This one is looking pretty cool, I think. It's a pretty funky one. Okay, so I'm gonna reset that to this face. Kind of like it. And that's pretty much it for the model part. Now it's time to talk about shading attributes and start cleaning this graph. So One thing we did earlier while experimenting with the colors, we get a pretty interesting effect when we were transferring colors from the inside, so this geometry. We would apply a color on this one and transfer it to our final model. And we had a pretty interesting effect because it would kind of give us a thickness effect. So you're gonna see in a sec. So that's basically what we had with orange and yellow color. But I'm just setting some white and black values. So we want to transfer the color, and let's increase blend width. Actually, I should swap those inputs. So second input is the interior. And here we go. As soon as we increase the blend width, you see how this white is spilling on the outside and kind of give us a sense of depth. And we basically could use those colors to drive some subsurface limitations for shaders. So what we need to do is create an attribute out of this color. And we'll use a pointvop. There are multiple ways to create attributes, but I like to use this one for beginner series. And we'll use a vector to float to just extract a float and not a vector. And let's use a bind export to export a custom float attribute we'll call thickness. So we'll only be using it in the next parts about rendering using Solaris. So in the meantime, we need to, call that thickness, make this clear. I'm actually gonna create a network box here so we know if we need to do some adjustments, that this is the thickness attributes. And we need to copy it to the main branch of our setup. So we'll use a attribute copy to transfer this attribute on our main pumpkin. So we don't want the color to be transferred. We want the thickness only. And as you can see, well, we can't actually see anything, but if we middle click, we see that we have a thickness attribute. And if we add the color, well, you can actually visually see what's going on, but we don't want to change our color. We are fine with that. So let's say from here, we want to change this color and create an attribute to separate our materials that we called inside. So out of these colors, let's check out the result. We can extract some black and white values. So I think using the green values, the fval2 would help us extracting a nice mask. So we'll use a fit range and contrast it like so. And this way we got a nice mask that can help us defining materials for render. So we'll export this into an attribute called inside. And that's pretty much it. So this is already on the main branch, no need to transfer it. So now we got color, inside, and thickness. So being able to control and create this kind of attribute is super important in a procedural project, because this way we don't need to rely on UVs and things like that, because every element can be baked onto the points. Now we're gonna tweak a bit this normal. Let's set it to primitive. I think Solaris is actually using normals stored on primitive. And we'll create this null called output pumpkin. And we want to probably apply some colors on this stem. Just for visualization purpose, we will probably make a legit shader for it. And okay, one last thing. I wonder if I destroy this face a bit too much. So maybe gonna reduce the steps. Maybe 6. Why not? It's a bit more subtle, I guess, but let's say we are happy with that. I'm gonna clean a bit this graph because it's getting a bit confusing. And since we're gonna reuse this setup quite a bit to generate variation, it's better if we clean it first. I mean, it's like cooking. Would you cook if your kitchen was messy and dirty? Well, probably it would be more difficult to work, or maybe You want to make things as organized and tidy as much as possible so you can cook some nice meals. That's the same spirit. It's also important to set colors to the nodes that are pretty important. That's why I like to set some greens on the parameters that could need some tweaking. So yeah, I think from there we are good to go. We'll code this pumpkin A. And finally, we will cache this geometry so that during the render, it doesn't need to reload all those nodes and generate the geometry all the time. So caching it, it's the way to go. So let's set up a name, pumpkin A. And from there, we can just save to disk and load from disk to actually load. At this point, we want to create variants for pumpkin. So I'm going to show you on one example. We're going to generate a pumpkin B. And the first thing I do is change the path of the file cache to make sure we're not going to override the geometry. So pumpkin B. So let's disable that for now and start to do some changes. So I'll go and start upstream, like way up in the graph when we had this pointvop and copy to points. And gonna probably change variation, the seed, probably the frequency as well to really get a very different shape from what we had with the pumpkin A. So let's see how it's looking once we generate the skin. So we still see the display of pumpkin A. Let's hide all the other context. So it's not bad, but we might do some more tweaks. Maybe the poly bevel. I think it's more the way that it's grouping our edges. There might be something going wrong. So that's the copy. And let's try to adjust the max input actually. Okay, this looks all right, I think. Yeah, looks like it would work. Let's see the result. Sure, why not? So we also could play with the radius of this pumpkin. So that's a bit weird. Let's squish it a little. And the initial amount of division, we could have played with that instead of the frequency actually. Or maybe both. In that case, I'm pretty happy with that. Then we had this mountain node for the deformation, the overall deformation. And yeah, I'm gonna go with something like that. Yeah, it's maybe less roughness. Let's see what it's looking with the carvings. And I'm gonna switch to one that I liked. I think it was input 3. Yeah, this one. It's pretty cool one. Let's try more breakup on the edges of this carving. So we'll increase the steps of the group expand. Yeah, we are getting some interesting things. Cool. And also the stem, we want to bring some variation with that. So maybe let's play with the bend. Maybe we may want to rotate it actually. So let's add a transform. Should have added that to the other setup too. It's always a handy control to have. And we'll trim a bit the length to something like 0.3 and probably get a thicker kind of stem. Something pretty thick at the base. Yeah. Let's set the uniform scale actually. That might be easier. Yeah. Pretty happy with that. So that would be how I approach the creation of a variant. And let's save to disk. And that's pretty much it for today. In the next video, we'll do an introduction to Solaris in the new release Houdini 18.5. So we'll see how we can use this tool to develop the look of our models and render them using CARVE. Thank you for watching, I hope it was useful. If it was, please consider subscribing and maybe check out my YouTube and Patreon for more videos. Thank you to all my patrons. Special thanks to Juan Iturbe, Adrien Mulryan, Philip Clack, Yana Sophie Gade, and Will Hoskins for their awesome support. Keep up the learning, and I'll see you guys next time.